In September 1981, a ranch dog in Wyoming killed an animal that, according to every scientist alive, did not exist anymore. The dog's name was Shep. What he dropped at his owner's feet was small, masked, black-legged, and nobody on that ranch had ever seen one before. The owner, a rancher named John Hogg, didn't think much of it, just another kill from a working dog. But his wife thought the animal looked strange enough to be worth showing to someone, so they brought it to a local taxidermist. He recognized it in seconds because he had studied the species in college, a black-footed ferret, and he knew exactly what that meant because the black-footed ferret was supposed to be extinct. The last confirmed wild population had died out 3 years earlier in South Dakota, and biologists had already begun writing the obituary for the entire species. Museum specimens, old photographs, a handful of scientific papers from the 1960s and 70s, that was what remained of the black-footed ferret as far as the scientific record was concerned. A dog's evening kill turned out to be the only sign left that the animal still existed anywhere on Earth. What happened over the next 4 decades would force people to admit something they were not prepared to admit, that saving this species meant listening to rules written not by scientists, but by the animal itself, and by an underground world almost nobody had bothered to study. But first, you need to understand exactly how strange this animal is, because everything that almost killed it comes back to one fact. To understand why the black-footed ferret came this close to vanishing, you have to understand what it actually is. It is not simply a rare predator. It is a specialist that evolved to do one single thing: hunt prairie dogs inside prairie dog burrows, using prairie dog tunnels as its own home. A ferret can travel kilometers underground without ever surfacing, moving through tunnel systems it did not dig, sleeping in chambers it did not build, killing the animal whose home it is borrowing. 90% of its diet is prairie dog, and the same is true of its shelter. Without an active prairie dog colony, a black-footed ferret has nowhere to live and nothing to eat. The species is not simply dependent on prairie dogs. It is welded to them. Whatever happens to the prairie dog happens to the ferret 1 generation later. And what happened to the prairie dog was one of the largest deliberate extermination campaigns ever carried out against a wild mammal in North America. Ranchers considered them a nuisance. Their burrows could break a horse's leg, and their grazing competed with cattle for grass. Starting in the early 20th century, the federal government itself distributed poison, first strychnine, later compound 1080, across millions of hectares of grassland, and ranchers spread it themselves on top of that. Prairie dog colonies that had once covered enormous stretches of the Great Plains, so large that a single connected colony in Texas was once estimated to hold tens of millions of animals, were reduced, in the space of a few decades, to isolated scattered patches covering barely 2% of their original range. Nobody was tracking what the poisoning was doing to the ferret, because almost nobody outside a handful of biologists believed the ferret still existed in meaningful numbers to begin with. The extermination of the prey was, without anyone intending it, the extermination of the predator, too. By the 1960s, the black-footed ferret was already considered close to gone. A small population was found in South Dakota in 1964, studied for over a decade, and by 1974, that population had also collapsed, likely from canine distemper, a disease that is almost always fatal to ferrets and spreads easily from domestic dogs. When the last of that population disappeared in 1979, the species was, for all practical purposes, extinct. 2 years passed with no confirmed sighting anywhere in North America. Scientists began referring to it in the past tense. Then, in 1981, came the night in Metisi. Shep's kill triggered an immediate survey of the surrounding ranch land, and biologists found something they had stopped expecting to find: a living, breeding colony of black-footed ferrets, thriving quietly on a working cattle ranch hidden inside one of the last large prairie dog complexes left in Wyoming. Nobody had looked there before, because nobody had thought there was any point. This particular stretch of ranch land had never been surveyed for ferrets, simply because the species was already presumed gone. By 1984, the population had grown to an estimated 129 animals, the largest number recorded in decades. Researchers began night spotting with flashlights, watching the distinctive green eyeshine of ferrets moving between burrows, mapping the colony one sighting at a time. For a moment, it looked as though the species had simply been overlooked rather than lost. It wasn't. The worst part of this story was still ahead. But here is where the story turns, because the very same disease that had wiped out the South Dakota population found Metezi too. In 1985, canine distemper swept through the colony. Within months, the population crashed from over 100 animals to barely a dozen. Biologists now faced a decision with no good options. Leave the remaining ferrets in the wild, and distemper would almost certainly finish what it started, capture them, and there was no guarantee captivity would work at all. No one had ever successfully bred black-footed ferrets in captivity before. In 1985 and 1986, biologists trapped every ferret they could find. By early 1987, the last known wild black-footed ferret on the planet was in a cage. The species existed nowhere except inside 18 individual animals, held at a single facility in Wyoming. 18 animals is not a population, it is barely a gene pool. Of those 18, only 7 would go on to reproduce and pass their genes forward. Everything alive today traces back to that number, and what happened next tested whether that gene pool was even viable at all. It almost wasn't enough. The breeding program that followed had to solve a problem most conservation efforts never face. Not simply keeping animals alive, but making sure they reproduced with enough genetic diversity that their descendants would not be crippled by inbreeding a few generations down the line. Every one of the 18 founders was studied, paired carefully, and their descendants tracked with the precision of a livestock pedigree. Some pairings failed, some litters didn't survive, but slowly, year after year, the number of ferrets in captivity climbed, from 18 to dozens to hundreds. By 1991, enough ferrets existed that biologists judged the population strong enough to attempt something that had never been tried with this species before, putting captive-born ferrets back into the wild. The first reintroduction, at Shirley Basin, Wyoming, in 1991, ran directly into a wall nobody had fully anticipated. Ferrets raised in cages, fed dead prey handed to them by keepers, had never had to hunt a live burrow-dwelling prairie dog, never had to avoid a hawk or a coyote circling above open ground. Survival rates in the first releases were devastating. Most of the reintroduced ferrets were dead within weeks, picked off by predators they had never learned to fear, or unable to catch prey they had never had to chase. 10 years of careful breeding, and the wild kept killing them anyway. The lesson was blunt. Breeding ferrets was not the hard part. Making a captive-born ferret capable of surviving as a wild predator was. So the program built something almost nobody expected from a rodent-hunting mammal: a training course. At the National Black-Footed Ferret Conservation Center in Colorado, kits were moved into outdoor pens containing live prairie dogs and real burrow systems, forced to hunt for themselves before release, exposed to the sight and scent of predators so they would learn, even in captivity, to be afraid. Keepers walked stuffed badgers and taxidermied raptors past the pens, let the scent of real predators drift through the enclosures, anything that might switch on an instinct that had never had a reason to activate inside a cage. It sounds almost too simple to matter. It mattered enormously. Post-release survival rates for preconditioned ferrets improved measurably over ferrets released with no such training. An animal that had spent its entire life inside a cage had to be taught, deliberately, how to be wild again before it could be trusted with its own freedom. And even that was not the end of the adjustments. Early reintroductions released ferrets directly onto open prairie, and the ferrets simply scattered, wandering away from the burrows meant to shelter them, easy targets the moment they surfaced in unfamiliar ground. Biologists changed tactics again. Instead of releasing ferrets into open colonies, they began placing them directly into pre-selected burrows at night, sealing the entrance loosely behind them, giving each animal a den to retreat to before it ever had to face a predator in the open. A detail that's small, which burrow an animal wakes up in on its first night of freedom, turned out to matter as much as anything else in the entire program. And even ferrets that survived the first week still depended entirely on one thing outside anyone's control: whether the prairie dog colony beneath them survived. This is where the story stops being about the ferret directly and becomes about an underground world almost no one had paid attention to, and about a threat that could undo everything in a matter of weeks. Sylvatic plague, a disease brought to North America around 1900, most likely arriving in fleas on ships from Asia, turned out to be catastrophic for prairie dogs, and prairie dogs have almost no natural resistance to it. A single infected flea can collapse an entire colony within weeks, killing the vast majority of animals in it. For decades, plague moved silently through prairie dog range, and every time it hit a colony that a reintroduced ferret population depended on, the ferrets above it starved or scattered along with the collapse below. Reintroduction sites that looked successful for years could be wiped out almost overnight by a disease that was, from the surface, completely invisible until the colony was already gone. A decade of work, gone in a single season, and there was nothing on the surface to warn anyone it was coming. For a long time, there was no good way to fight it. You cannot vaccinate a wild prairie dog colony one animal at a time across tens of thousands of hectares. Insecticide dusting of burrows to kill the fleas carrying plague helped, but it was slow, labor-intensive, and covered only a fraction of the ground that needed protecting. Field crews had to walk each colony by hand, puffing insecticide powder down individual burrow entrances one at a time, across landscapes that could stretch for kilometers, and a single missed section could let the disease back in through the gap. Entire reintroduction sites that biologists had spent a decade building up could be reduced to a handful of survivors within a single plague season, and there was no way to predict exactly where or when it would strike next. The solution that eventually worked came from an unlikely direction: an oral plague vaccine, developed specifically for prairie dogs, delivered inside a peanut butter-flavored bait pellet that the animals would eat voluntarily. Prairie dogs, it turns out, will eagerly eat something that tastes like peanut butter, whether or not there's a vaccine hidden inside it. But distributing bait pellets by hand, walking hundreds of hectares of prairie dog burrow, was still too slow to keep pace with plague outbreaks. So biologists turned to drones. Custom-built delivery drones, guided by GPS, now fly low over prairie dog colonies and drop the bait pellets in a precise grid pattern at a rate far faster than any team on foot could manage. Each drone capable of vaccinating a colony across dozens of hectares in a single flight. It is a strange image. An aircraft, built for a rodent nobody wanted a century ago, now protecting the one animal whose entire survival depends on that rodent staying alive. The results were measurable in a way the hand-dusting era never was. Colonies that received regular drone-delivered vaccine doses showed significantly better survival through plague outbreaks than untreated colonies nearby. And because the drones could cover so much more ground per flight than a team on foot, vaccination could now keep pace with an outbreak instead of trailing behind it by weeks. For the first time since plague arrived in North America, prairie dog colonies had a real chance of surviving contact with it, and every ferret population sitting above those colonies inherited that same chance. If a species being pulled back from extinction one drone flight at a time is the kind of story you want more of, this channel exists for exactly that. Subscribe, because the next recovery is stranger than this one. Even with the vaccine, one problem remained that no amount of careful breeding could solve on its own: genetic diversity. Every black-footed ferret alive today descends from a group that, at its narrowest point, numbered 7 individuals that successfully reproduced in captivity. 7. That bottleneck means the entire species carries a genetic pool far smaller than what a healthy population would normally have, and a population this narrow is vulnerable to exactly the kind of disease outbreak that had already devastated it twice. Every new generation is, in a sense, working with the same limited genetic material, shuffled slightly differently, but never expanded. There was no way to add new genes to a species with no more wild individuals left to find. Or so everyone believed until someone remembered a freezer. This is where the story takes its strangest turn. In the 1980s, before the last wild ferrets were trapped, biologists had the foresight to freeze tissue samples from several individuals, including one female named Willa, whose genetic line, it turned out, had left no living descendants among the founders of the captive population. For over 30 years, those cells sat frozen, genetically valuable but functionally useless, a version of the species that no longer existed in any living animal. In December 2020, using Willa's frozen cells, scientists produced a clone, a black-footed ferret named Elizabeth Ann, the first cloned endangered species native to North America. She was not simply a copy of an existing animal. She was, genetically, a ferret from a lineage that had otherwise vanished, brought back into a population that badly needed exactly the kind of diversity her genes carried. It was not a stunt. It was an attempt to reopen a genetic door that had been closed for 4 decades. Since then, additional clones have been produced from the same frozen line, an effort to widen the gene pool of an entire species using cells that were nearly forgotten in a freezer. The plan going forward is not simply to display these clones in captivity, but eventually to breed them into the working population, so that Willa's genetic line, absent from every living ferret for 40 years, finally rejoins the species it once belonged to. None of this guaranteed success on its own. Cloning added genetic diversity, but every reintroduced population still had to survive on the ground, in real prairie dog colonies, against real disease and real predators, year after year, without a guaranteed outcome. That work fell to a small number of people, willing to spend decades on a single species most Americans have never heard of. Among them is Travis Levieri, a biologist who has spent more than 25 years monitoring wild ferret populations in South Dakota, trapping, tagging, and tracking individual animals across multiple reintroduction sites, watching some populations grow and others collapse under plague, year after year, with no assurance that the species would ultimately hold on. His work happens mostly at night, driving slow loops across prairie dog colonies under a spotlight, watching for the same green eyeshine that first confirmed the Metaitse population decades earlier, trapping individual ferrets just long enough to check their health and record their location before releasing them back into the dark. It is quiet, repetitive work, done at night, on behalf of an animal almost nobody driving past that same prairie would ever notice was there at all. It is the same pattern found again and again in successful long-term conservation work. Not a single dramatic rescue, but one person, or a small handful of people, choosing to keep showing up for a species long after the initial excitement has faded and the difficult repetitive monitoring work is all that's left. The numbers tell you how narrow the margin still is. As of the most recent counts, only a few hundred black-footed ferrets exist in the wild, across all reintroduction sites combined, spread across parts of Wyoming, Montana, South Dakota, Arizona, and a handful of other states, plus a captive population held as an insurance policy against another collapse. Compare that to the tens of millions of prairie dogs that once anchored the ferret's range across the Great Plains, a habitat now reduced to scattered, disconnected fragments. The species has not been saved in the way that word usually implies. It has been kept alive, deliberately, continuously, by people who understand that the moment sustained intervention stops, plague or habitat loss could undo 40 years of work within a single season. And every one of those reintroduction sites depends on the same thing the ferret always depended on: a living prairie dog colony beneath it. That is the part of this story that is easy to miss if you only look at the ferret itself. Prairie dogs are not simply prey. Their burrows aerate and irrigate the soil, giving rainwater somewhere to soak in rather than run off the surface. Their constant grazing keeps grass short enough that certain other grassland species can move through it easily, which is why the colonies these animals build often support far more biodiversity around their edges than the surrounding untouched prairie. Burrowing owls nest almost exclusively in abandoned prairie dog burrows, having no ability to dig their own. Swift foxes den in the same tunnel systems. Mountain plovers nest in the short grazed grass inside active colonies. Rattlesnakes, badgers, and a long list of other species use the same tunnels for shelter at different points in the year. Dozens of species, some of them found almost nowhere outside a healthy prairie dog colony, rely either directly or indirectly on the habitat that colony creates. Saving the black-footed ferret required, as a precondition, protecting an animal that people had spent a century trying to eliminate. You cannot bring back the predator without first admitting the pest you exterminated was the foundation the entire ecosystem stood on. Even today, that fight is not finished. In many parts of the ferret's historic range, prairie dogs are still legally classified as pests, still poisoned on private land, and still shot for sport in some states, entirely legally, even inside counties that border active ferret reintroduction sites. Every acre of prairie dog colony lost to poisoning or shooting is an acre that can never support a ferret again, no matter how many animals are bred, cloned, or vaccinated. The species recovery plan depends, in the most literal sense, on convincing landowners across multiple states to tolerate an animal their grandfathers spent a lifetime trying to eliminate. Some of that tolerance has come through compensation programs and safe harbor agreements that protect ranchers from added regulation if ferrets are found on their land. Some of it has simply come through decades of relationship building between biologists and the same ranching communities that once saw prairie dogs purely as a threat to their livelihood. Neither approach guarantees success. Both are still being tested, colony by colony, ranch by ranch. Right now, that is the real shape of this recovery. It was never simply about breeding enough ferrets. It was about relearning, piece by piece, everything the species actually needed. A prey animal with no natural resistance to a foreign disease, a genetic bottleneck narrow enough that a single outbreak could end the species for good, a predator so specialized it could not survive being handed food in a cage, and a habitat that had been deliberately destroyed by the very people who would later have to rebuild it. Nothing about that list could be guessed from a desk. Every part of it had to be discovered the hard way, usually after a failure, sometimes after a population had already been lost. The black-footed ferret did not ask to become one of the most intensively managed species in North American conservation history. Every clone, every drone flight, every carefully arranged captive breeding pair exists because the alternative, doing nothing, had already been tried by default for most of the 20th century, and it had produced extinction in the wild. What replaced it was not a single breakthrough, but 40 years of adjustment. Learning that captivity alone does not make a wild animal, that a vaccine can be delivered by air, that a cell frozen decades earlier can still matter, that an entire species can be rebuilt one narrow gene pool at a time if enough people refuse to give up on it. A dog named Shep did not save the black-footed ferret. He only bought it a little more time. What has kept the species alive since then is something less dramatic and far harder to sustain. 4 decades of people paying close enough attention to a nearly invisible, burrow-dwelling predator to notice exactly what it needed, and then doing that over and over, long after anyone outside a small circle of biologists was still watching. The species is not out of danger. It may never be, not in the way people usually mean when they say a species has been saved. A few hundred animals scattered across a handful of states, dependent on continued vaccination flights, continued captive breeding, continued goodwill from ranchers who could, at any point, decide the arrangement is no longer worth it, is not a stable population in any traditional sense. It is a supported one, held in place by continuous human effort, in a way almost no wild animal on the continent is. But it is alive, breeding, and slowly, unevenly, spreading back into ground it had not touched in half a century. That is not nothing. For an animal that was, for all practical purposes, extinct twice in the 20th century, alive and spreading is close to the best outcome anyone in 1987, watching the last 18 ferrets go into cages, had any real reason to expect. If you want to keep finding the animals and the people quietly holding a species together like this, one recovery at a time, subscribe. There's another one coming.